Happy Friday, ladies. This time it's a little bit different when I'm doing this. I'm sitting in my classroom and you're not here. It's kind of weird. Anyway, today we are going to be talking about the body defenses. Our body has three basic lines of defense that defends against things invading our body and helps to protect from damaging our tissues or damaging cells. This is now chapter 31. So we're done with chapter 30. That was the cardiovascular system. This is now chapter 31. On Monday, we'll dive into the reproductive system, which is chapter 34, and that will take us all the way through to the end. The end is in sight. All right, so as I said, we have three lines of defense. The first line of defense really is about preventing foreign things from getting into our body. And so this includes a bunch of surface membrane barriers. Surface membrane barriers are things like our skin, physically keeping bacteria or other pathogens. Pathogens are things that cause disease, keeping them out of our bodies. In addition, this includes things like the acidic pH, so low pH, of our skin secretions. This helps to inhibit bacteria from growing on the surface of our skin. Our stomach is full of hydrochloric acid. Spell that as best you can. We'll worry about it later. Hydrochloric acid. The big thing here is it's an acid, so it's going to kill pathogens. It also helps to break down our food, which is another nice little benefit. Our saliva and tears contain enzymes that destroy bacteria. And mucus, lovely mucus, traps microorganisms that try to get into our digestive system or our respiratory system. All right, so all of those are trying to keep these pathogens out of the body. But sometimes they break through this first line of defense, and so we get to the second line of defense. The biggest part of this second line of defense is the inflammatory response. The inflammatory response occurs anytime a cell is damaged or a tissue is damaged. So it could be because a bacteria has managed to get past your first line of defense, or it could be because, oh, I got a paper cut. Okay, so I did damage to the cells, and so that's going to kick the inflammatory response into gear. When the cells are damaged, they release chemicals like histamines. Now, I'm sure you've all heard of antihistamines because we take antihistamines to counteract the effects of histamines. So what the histamines do is they cause this inflammatory response, and there are four qualities of the immune response or inflammatory response. Redness, so the area becomes red because blood is rushing to the area. Heat, which is also caused by the increased blood flow. Swelling, because the capillaries become leaky. Remember, we talked about how you're leaking all the time anyway? Well, the histamines cause those capillaries near the damaged tissue to become leaky, so it swells up. And the fourth quality is pain. That swelling puts pressure on the nerves. And anytime our nerves are overstimulated, we perceive that as pain. So the four qualities are redness, heat, pain, and swelling. Now, as I said, the redness and heat are caused by increased blood flow to the area. The idea behind that is that we're bringing nutrients and oxygen to the affected area, which will increase the metabolic rate of the cells, which will help them to heal faster. Swelling, especially if it's in a joint area, is trying to immobilize that joint. Keep it from moving so you don't do further damage to the tissues. And we've talked about pain before, the importance of pain. Mrs. Oakman, it hurts when I do this. Then don't do that. Your body's trying to tell you something. There's something wrong if it hurts. And so it's giving you information and giving your body information so that you can heal what has been damaged. So all of the things that happen, for instance, when we catch a cold and we get all mucusy and our bronchial tubes get all swollen up, all this is because of the inflammatory response. So all of those things that are happening that make us feel miserable, that's our body's way of trying to get us to heal. So when we take antihistamines to stop those reactions, we temporarily feel better, but we're also stopping our body from doing its natural job of making us better, of getting us better. So I'm not suggesting that you never take antihistamines. I'm suggesting if you're not that miserable, you might get over your cold faster if you don't take antihistamines to get rid of the symptoms. So by taking them, we can prolong how long the actual illness is going to be because our bodies haven't had the chance to naturally fix us. Excuse me. However, if you are very, very miserable, you want to take something to help out because you don't want to get to the point where your bronchial tubes, those tubes that lead to your lungs, are so swollen you can't breathe anymore. That's not good either. Okay, so there is a point at which definitely you want to take the antihistamines because the effects can be fatal. That's not good. All right. So if the inflammatory response is not enough, our third line of defense kicks in. And our third line of defense is the actual, what we refer to as the immune system. The immune system, the immune response, has three qualities of its own. The first quality, it is antigen specific. Antigens are just any substance that is capable of exciting an immune response. And that immune response is what we're going to be talking about now. So it's antigen specific, meaning that we're going to talk about the cells of the immune system, that they target specific antigens. So for instance, some of our cells are particular for the flu, while other cells are particular for TB. We'll just go with TB. Okay. Some of them might be particularly responsive to a particular virus or a particular bacteria, E. coli. The second quality, and we've talked about this before, is that the immune system is systemic. There is no one place we can point to and say that's the immune system. The immune system goes where it's needed, wherever there is tissue damage being done. And finally, it has memory. This is the idea behind vaccines. So when you are vaccinated for something, let's say you got the flu vaccine this last fall, your body, the vaccine was a weakened form of the virus, of the suspected virus that would cause the flu. It was a weakened form of that. So your body learned what that specific antigen was. And so if you were exposed to that virus again later on this fall or winter, your body knew how to fight it before the inflammatory response kicked in or before the immune system kicked in. So it has a memory of this is how we fight this particular antigen. And so the next time we can intensify our fight against it if we see it again and get rid of it before it does any damage to our bodies. Pretty cool stuff. All right. So the immune system has two big parts to it. We have humoral immunity. Body humors are not funny. Instead, body humors, it's no fun when you guys aren't here to look at me funny or laugh at my jokes. Body humors are any body fluids. So it could be our blood, it could be our plasma, it could be our lymph, they're any body fluids. And so humoral immunity is a chemical-based immunity. So we'll flip over here for a second. There we go. It is regulated by B cells. B cells are a kind of white blood cell. And B cells produce chemicals called antibodies. And the antibodies are actually the fighters. Now, the B cell, when it encounters an antigen, starts cloning itself. And there are two types of clones. So these are B cell clones. There are plasma cells, not to be confused with blood plasma. These are actually cells. Blood plasma, remember, is chemical. There are plasma cells, and then they also form memory cells. So there's part of that memory I was just talking about. The plasma cells are antibody factories. They produce thousands of antibodies per second. And then they die. But we have those memory cells, so it's all good. So let's take a look at the structure of antibodies. Antibodies have kind of a Y-shaped structure. Here we go. Okay, so antibodies are made of proteins. They're polypeptide chains. And yes, there is a reason why I'm making the ends of this a different color. So there's a little antibody. This blue part on my antibody is the variable region. The purple part on my antibody is the constant region. The variable region determines what antigen this antibody will bind to. The variable region determines which antigen this antibody will bind to. The constant region tells us what class of antibody it is. There are 5 classes. We're not going to go into the classes. I always think of these antibodies like a key. And if you were standing in front of me right now, I'd take my keys out of my desk and hold them up to you. And hold up, for instance, my Duchenne key. By looking at the whole handle of the key, you can tell it's a Duchenne key. All the Duchenne keys look like that way. If I hold up my car key is really obvious. It's a little flip key thing. You know that belongs to a car. That's the constant region of an antibody. Same thing with my house key. You could probably figure out that that's my house key. But presumably, my house key only opens my house. That's the variable region of the antibody. It's specific to the antigen, just like my key, presumably, is specific to my house. Or my car key is specific to my car and isn't going to open any of the other VW Beetles out in the parking lot. So these antibodies help to neutralize antigens. So that's one big part of our immunity, our immune system. The other big part is cellular immunity. Cellular immunity, as its name suggests, is regulated by cells. Once again, these are a specific kind of white blood cell. And you've probably heard of these before. These are T cells. With T cells, it's the actual cells themselves that are regulating the immunity. And once again, when the T cell first binds, just like with B cells, when the T cell first binds to an antigen, it starts cloning. In this case, there are more different kinds of clones. We'll talk about 4 of them, just really briefly here. There are cytotoxic T cells, also known as killer T cells. And these guys are little assassins. They go and find antigen cells. So these aren't going to work too well on viruses, but they work well on cells. Could be foreign graft cells, like if we give you the wrong type of blood. If you have type A blood and we give you type B blood, these guys are going to go kill those type B blood cells. And the way they do this, as an assassin, the way that they do this is they inject the cells, the foreign cells, with a chemical called perforin. Perforin causes the cell to lyse. Remember, lyse means to break, so that's how it's going to kill the cell. And the way they do this, they go along and they inject it with perforin and move on. The cytotoxic T cells do. They move on. And then so they're going and injecting other cells with perforin, other negative cells with perforin, and they're long gone by the time the first one they injected explodes. So they're just little assassins. Another type of T cell is a helper T cell. Helper T cells secrete lots of chemicals to help activate B cells, to recruit other immune cells to the area, they help to enhance the inflammatory response, so that second line of defense, they help to enhance that. So they're gonna just try and get everybody all riled up to go fight against this antigen that has invaded our bodies. A third type of clone, T cell clone, are regulatory T cells. Regulatory T cells help to keep our immune system in check. So once the cytotoxic T cells and the helper T cells have been working really hard to make sure that this antigen is destroyed, the regulatory T cells will say, okay, you guys have done your job. We don't need as many of you around. We don't need to enhance the immune response. So we're actually reducing the amount of energy that we're putting into an immune response if we don't need it anymore. And this is a very positive thing. So as long as we've taken care of the antigen, this is a good thing. If the regulatory T cells didn't kick in and reduce the immune response after the antigen has been destroyed, this can lead to autoimmune diseases. I don't know if you guys can read that or not. It's kind of hard to read on my computer, so I'll try it in a different color. Autoimmune disease. Autoimmune diseases are diseases where the body attacks its own cells. So things like multiple sclerosis, rheumatoid arthritis, those are examples of diseases where the body, in the example of MS, it's where it's attacking that insulation around the neurons that we talked about, breaking down that insulation. With rheumatoid arthritis, it's destroying the cartilage in the joints. So if the regulatory T cells don't keep the immune system in check, it can lead to autoimmune diseases. And then last but not least on our list, we want to mention also that there are memory T cells. So once again, going back to producing memory, so the next time we encounter this antigen, we can defeat it. All right, ladies, so that's it. That's all we're going to do with the immune system. If you have questions, please bring them to class with you on Monday. We will start reproduction on Monday, but I will give you some time to go back over this and see if there's anything that you have questions on. All right, I hope that this wasn't too awkward, and I hope I know how to turn this off now.